and welcome to this series of case studies and experiments using PicoScope. That's PicoScope software and also NVH as well, so that's in the Pico Diagnostics software. It really follows cases that I feel no other tool would have got us out of trouble, would have helped us diagnose conclusively what the problem was. In some cases, you don't end up with a diagnosis. You know exactly the depth of repair required, and to actually repair is beyond economical repair. Nevertheless, you've got that evidence that stops those awful incidents happening where it's an awkward discussion or it just becomes a scrap vehicle. In most cases, or it can be that is the case. All right, so starting immediately then with the 3-cylinder Volkswagen 1.2 engine. This vehicle came in with P0172 System 2 Rich, but also another code, the one to cling to, which was P0106, which is manifold pressure implausible signal. The question here, does this signal look okay? Could this be a mechanical fault? And what about valve timing? So it just gets your sort of mind thinking about, okay, what could give us these symptoms and these DTCs? On the left, we can see there that manifold pressure is 1.669 at idle. At wide open throttle, naturally the voltage increases. And then you take your foot off the gas pedal, you see that voltage decrease. Zooming in on the right-hand side, I actually don't see anything wrong with this signal at all. Voltage is correct. We can see the pulsations in the signal, which is attributed to intake and possibly overlap as well being felt within the intake manifold. And that maximum voltage at 4.013 volts at wide open throttle. So on the surface, that signal is present and is arriving at the ECU. So I think at that we should probably move on and think more outside the box, think about valve timing. Before we do, we're going to need a known good. Doing cam and crank correlation is great. Once you've got that capture, where do you go from there? What does a good one look like? Well, thanks to the waveform library here in this scenario, we have a perfect match, both engine code, even model as well. Remember, you don't have to search for the exact model. It may be that we have a Volkswagen Polo here. It might be that the same engine is fitted in something like a Skoda Fabia or something similar. Engine sort of code is the guide really. And here we have it. What else could result in P0172 and more importantly the manifold pressure implausible, that P0106? And it is valve timing, and here's the proof before we actually commit to dismantling this engine. So on the left we've got what I've called the faulty example, and you see here that we've captured the camshaft and crankshaft signal. We've used the first rising edge of the large lug on the camshaft. This is the blue waveform. And from the missing tooth to that first rising edge on the cam, so the missing tooth on the crank to the first rising edge on the cam, our falling edge count is 30. On the good crank, this is in scope view 2, so this is our waveform that we've downloaded from the waveform library and compared against the vehicle in the workshop. We can see something different altogether. Same again from the missing tooth on the crankshaft to the first rising edge of the large lug on the camshaft. We're measuring a falling edge count between the rulers, should have mentioned that before, between the time rulers at 29. We are a tooth out on the crankshaft, which is ultimately half a tooth on the cam. One tooth on the crank is equivalent to 6 degrees of crankshaft rotation because it's 360 degrees divided by 60 teeth. That's then resulting in a 3 degree error at the camshaft. So there we have it. We're going to have implausible manifold pressure because our correlation between valve open and close events does not correlate with crankshaft and ultimately piston position. The fix there, timing chain. About timing chains and about measuring cam and crank correlation, a word to the wise here. Try not only measuring this correlation during idle, try it also during the push-pull on the chain or the belt. So perhaps take a reading when it's idling. Remember, if it has VVT, so it's VVT disconnected. During acceleration, there will be a variation because there'll be a pull on the chain or a push depending. And then of course on the overrun, so try to take 3 measurements. And I would add a 4th actually to that. I would also bring in cam and crank correlation when the engine is cranking, because cranking has quite an adverse effect on chain. If ever there's any slack, we may not have maximum oil pressure while we're cranking. It may reveal something. Thinking of, let's say, a 4-cylinder diesel engine where you've got a lot of compression every 180 degrees of the crank rotation, maybe there's a bit of flap in the chain that is detected more so during cranking than perhaps would be visible during idle. Okay, that's it. Thank you for watching, and any questions please send them over, and we'll endeavour to answer them as ever. All right, take care.